dear children, this is Roshni from Learno Hub, the free learning platform where you can learn physics, chemistry, maths, biology, social science, English grammar, tips and tricks, motivational videos, all for free at learnohub.com. We also have our offline pen drive courses which are at a very minimal price. The links are given in the description below. So what's our agenda for today? So today I am here with the part 3 or the third video of the video series on electricity class 10 science, and in this video today we are going to talk about electric circuits. Now that's super duper important. Okay, and in electric circuits we are going to talk about the various combination of resistors in series, resistors in parallel, and we will solve many numericals based on that. So this is a super duper important video, so watch till the end, and now let's get started. Now, how do we represent an electric circuit? An electric circuit is represented by a circuit diagram. Like for example, when we were going through the lesson on light, when we were studying about reflection, refraction and image formation, we were representing the image formation with the help of ray diagrams. Similarly, we will represent electric circuits with the help of circuit diagrams. Now, how do we draw circuit diagrams? Circuit diagram is drawn using the conventional symbols of different circuit elements, because whenever we talk of any electric circuit, that circuit will have several elements, right? That circuit will have resistors, it can have inductors, it will have batteries, it will have wires, it will have switch, it will have voltmeter, it will have ammeter. So there are so many things that will be present in a circuit. So how do I represent all those things? So there are some conventional symbols which are used for each of the circuit elements. So now I will tell you about all such symbols. So generally whenever we want to represent a wire in a circuit, how do we represent? We represent it by a straight line. Suppose if I want to represent a cell, we represent it in this way. So this represents the positive terminal and this represents the negative terminal. Now let us suppose if I want to represent a battery or a group of cells. In that case we can represent it like this. So this bigger one is the positive terminal, smaller one is the negative terminal. So this is how we represent a battery or a group of cells. How do I represent a switch or a key? A key or a switch. It is sometimes known as key, sometimes known as switch. It is represented as this. So when it is represented like this, that means the key is open or the switch is open. So that means the switch is off. Sometimes the key is also represented like this in a circuit. So both of them mean the same thing. That means no current flows in the circuit. The switch is off. Now if you want to represent a key or a switch which is closed, then you represent it with a dot. And this one you represent like this. That means the key is closed. You have pressed it. That is what it means. Right? So this means the switch is off. This means the switch is on. How do I represent resistance? Resistance is represented like this. Now it is represented like this if the resistance has a fixed value. I mean, if I know that, okay, the resistance of this object is 2 ohms. The resistance of this object is 5 ohms. If it is of fixed value, then it is represented like this. But if you want to represent a variable resistance, now what do I mean by variable resistance? Sometimes I want to keep a variable resistance so that during my experiment or during the operation of the circuit, the resistance should be able to change its value on its own. That kind of resistance is known as a variable resistance or a rheostat, and that is represented like this. So this represents a variable resistance, so that this resistance can change its value depending upon the requirements of the circuit. Now, how do I represent an ammeter? What is an ammeter? It is an instrument which is used to measure current in a circuit. Like how we have voltmeter to measure voltage or potential difference. So this is denoted by A. So this is how we represent ammeter. Similarly, we represent a voltmeter. In that case, we will have V to represent voltmeter. Now, how do we represent wires which are joined? Let us suppose there is one wire going like this, there is another wire going like this, but these two wires are joined. That means this wire is joined to this wire, this is joined to this is joined to this. This is how we represent. But if I want to represent that wires are crossing each other without joining, wires cross without joining, how do we represent that? That is represented in this way. That means this is one wire and this is another wire, but these two wires are not connected. So that this is how it is represented. But in this case, it means that this wire and this wire are joined at this point. So when we draw circuit diagrams, all these things make difference, right? Because looking at the circuit diagram, sometimes you first draw the circuit diagrams and then you actually make the circuit in your lab, right? So now how does a circuit look like, taking into consideration all the circuit elements? Let us suppose if I have a circuit where I have a switch, I have a battery, I have a resistance, and then I have a bulb which is connected to the circuit. So how do we draw that circuit? First of all, I have a battery or a cell. This is positive, this is negative. This is connected to a resistance, which in turn is connected to a bulb, and then there is a switch in this circuit. So this resistance is of resistance R. This is a battery which can produce a potential difference of V volts, and this is a key. As long as the key is open, there will be no current flowing in the circuit. So the bulb will not glow. Now as soon as you close the switch, as soon as you switch it on, what happens? The bulb starts glowing. Right? So this is how we draw circuits with the help of these conventional symbols of circuit. Now it is time to talk about resistors. So see, since you are studying electricity for the first time, so I am just giving you an overview of the concepts related to electric current. I am not going into depth. You will study about the same topic on electricity in your class 12th as well, wherein we will study about each of these topics in full depth. So that time you will understand things even better than this. But since this is the first time you are studying this lesson, so we will just try to get an overview, or we will just try to get an idea about what is electric current, why electric current arises, what is an electric circuit, and here we will talk only about resistors in this lesson. So in order to study about the combination of resistors, first we should know what are resistors. So we talked about resistance in the last few slides, right? So resistance was the property of any object to resist or to oppose the flow of current. So resistors are those objects. Resistors are the materials which resist the flow of current. So resistance is the property and resistors are the objects. So there are different types of resistors available. One is known as wire bound resistors, and there is another resistors called carbon resistors. If you go to your science lab, you would be able to see these kind of resistors available there. They are very small bits of resistors, but when you put them in circuit, they try to resist the flow of current. Now, what is the magnitude of the resistance? How much is the resistance of these resistors? That also we can calculate by looking at the colors present on this resistors. But how do we calculate that? All those things are not needed for you at this level. You will study all those things in class 12. What is wire bound resistors? Wire bound resistors look somewhat like this. It is like some metal over which the number of turns of a wire is present. So that entire thing also acts as resistor. So these are broadly the two classification of resistors. Now when we make electric circuits, when we design electric circuits, we often use resistors. So why do we use resistors in electric circuits? In order to prevent huge amount of current flow through the circuit, because it might happen then that when extremely high amount of current flows through a circuit, it might spoil the electrical elements present in that circuit. For example, let us suppose you think of your refrigerator, or you think of any electrical appliance at your home. If a very huge amount of current passes through that circuit, many of the components get damaged. So to prevent that huge amount of current flow through any circuit, we use resistors. Now there are different ways in which resistors are arranged in a circuit. In fact, there are two ways in which resistors are combined with each other. Now, why are resistors combined? Let us suppose in order to design a circuit, you have a specific requirement. Suppose you are designing a circuit and you want that only this much amount of current should flow through the circuit. Say your requirement is only 5 amperes of current should flow through the circuit. Maybe you are designing something. You want 5 amperes of current. For that, maybe you want a specific value of resistance to be present in the circuit. So how do you get that specific value of resistance? Because in the previous slide I showed you these resistances, right? These resistances are available in the market, but all possible values of resistors are not available. For example, maybe suppose the value of this resistance is 100 ohms. Again, you have a resistance of 105 ohms available in the market. You have another resistor of 200 ohms available in the market. But let us suppose that in the circuit you want a resistor of 99 ohms and there is no resistor with resistance 99 ohms available in the market. So what will you do? In such cases, what do? We combine the resistors which are available to get that desired value of resistance. Getting my point? So in order to make our desirable circuits, when we want some specific value of resistance, sometimes we combine resistors to get that particular value of resistance. So there are two ways in which resistors can be combined. First is resistors combined in series. The second one is in parallel. So one is a series combination and the other one is a parallel combination. So in this lesson, we will see how resistors are connected in series and what happens when the resistors are connected in series. Similarly, we will also talk about the parallel combination of resistors. So what do I mean when I say that the resistors are connected in series in a circuit? It means that all the resistors are connected one after the other in this way in a circuit. Or you can represent it in a circuit diagram, you can represent it like this. So what happens in this kind of a combination? Let us suppose this is how the resistors are connected. Let us take this example. Let us assume that there are 3 resistors R1, R2 and R3 which are connected in a circuit, right? And let us say some amount of current I flow through this circuit. So if I flows through resistor R1, that means the same amount of current will flow through R2 and R3 as well. So through each of them, the same amount of current is flowing. So when resistors are connected in series, current flowing through each of them is the same. However, the potential difference across each resistor is different. If the potential difference across R1 is V1, potential difference across R2 is V2, potential difference across R3 is V3. So in a series combination, one point to remember is that current through each resistor is same. That is one thing to be noted. And the second thing is potential difference across each resistor is different, right? So now what would be the potential difference across R1? V1 will be equal to IR1, that is according to Ohm's law. So the resistance is R1 and the current flowing through this R1 is I. So this V1 will be equal to IR1. Similarly, V2 will be equal to IR2 and V3 will be equal to IR3. So what would be the total potential difference between these 2 points? The total potential difference between these 2 points, V, will be equal to V1 plus V2 plus V3. Now the total potential difference in this circuit can be written as I into R equivalent, where R equivalent is the equivalent resistance of this circuit, that is the net resistance of this circuit. That is also in accordance with Ohm's law, that is if V is the total potential difference between these 2 points and I is the total current flowing through this circuit and R equivalent is the equivalent resistance of this circuit, we can say V is equal to I into R eq. So this will be equal to I R1 plus I R2 plus I R3. So from this we can say I R equivalent is equal to I into R1 plus R2 plus R3. So this I and I will get cancelled. So we can say equivalent resistance of a circuit in which the resistances are connected in series is equal to the sum of the resistances. So this is the equivalent resistance of a circuit in which the resistors are connected in series. Now let us talk about the parallel combination of resistances. When we talk of parallel combination, we mean the resistors are connected in this way. I mean the resistors are not connected one after another. Instead, both the ends of the resistors are connected to each other. That means if you see this end of all the resistors are connected together, again the other end of all the resistors are connected together. So in terms of circuit diagram, you can represent it like this. So let us take this example. Let us suppose we have 3 resistors R1, R2 and R3 which are connected in parallel. That is, one end of all of them is connected together, again the other end is connected together. Let us suppose this is R1, this is R2 and this is R3. So if current I flows in the circuit and it enters here, so what would be the current flowing through each of them? Current flowing through each of them will be different, because this current I will come here and it will get divided into 3 parts, I1, I2 and I3. Right? So I1 will flow through R1, I2 will flow through R2 and I3 will flow through R3. However, the potential difference between these 2 points is the same. Therefore, the potential difference across R1 is R2 and R3 are same. So in case of parallel combination, what happens? Current through each resistor is different. However, the potential difference across each resistor is same. That means in parallel combination, the potential difference across each resistor will be the same. So in this case, we can say that the total current flowing through the circuit is equal to I1 plus I2 plus I3, because this current gets divided into 3 parts. Now from Ohm's law, we can say that V, that is the potential difference across these 2 points, will be equal to I into R equivalent of the circuit. So this can be written as V divided by R equivalent. I1 can be written as V by R1, I2 can be written as V by R2 and R3 can be written as V by R3. So from this we can write 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this equation represents the equivalent resistance of a parallel combination of resistances. So this is how we calculate equivalent resistance in a circuit where the resistors are connected in parallel. So these are the 2 types of combination of resistors which are possible. So depending upon our requirements, we arrange resistors in a circuit. So let us try to look at some of the problems based on these calculation of equivalent resistance. Let us suppose if a circuit is given like this and I ask you to calculate the equivalent resistance of this circuit between these 2 points A and B. So what will be in order to find out the equivalent resistance, first see how is the current flowing in the circuit. Now these 2 dots, these 2 bubbles show that these 2 are connected to the remaining circuit, I mean some battery or something. So this completes the circuit. So let us suppose some current I flows through the circuit. When I reaches at this point, it has an option to move through this resistance and another option to move through this resistance. But if you look at this resistance is in air. It is not connected to anything. So the current cannot flow through this, because current will never flow. I mean, let us suppose if you keep a piece of wire on the ground, will current flow through it? It will not flow, because in order that current flows through a circuit, the circuit has to be a closed circuit. There has to be a battery connected to the circuit which will provide the potential difference between the two ends of the wire. But in this case, if you see, this wire is hanging in air, so no current can flow through this wire. So the entire current will flow through this resistance. So what do you see here? The amount of current flowing through this resistance and this resistance is the same. That means what kind of combination is this? It is a series combination, because same current flows through both the resistances. So what will be the equivalent resistance? Equivalent resistance will be the sum of the resistances, that is 7 plus 5 ohms, which is equal to 12 ohms. So 12 ohms would be the equivalent resistance of this circuit. Let us look at the next problem. Here also we will have to calculate the equivalent resistance between these 2 points A and B. So let us assume that some current I flows through this resistance. It reaches this point. Now it has two options. Either it can move through this path or it can move through this path. Now if you see, if the current moves through this path, it will have to overcome these resistances which will try to oppose the current. But if it moves through this path, there is no resistance at all. So what do you think? Which path will current prefer? So current will prefer to move through this path, because there is no resistance along this path. So the entire current will flow through this path and there will be no current flowing through this path. Since no current flows through this path, therefore these two resistances doesn't play any role. So that means the current flows through this 3K resistance and then it flows through 5K resistance. This shows that, so from here we can see that, let us call this as CD. No current flows through CD, and we also see that same current flows through 3 ohms, that is 3K and 5K. Therefore 3 kilo ohms and 5 kilo ohms are in series. So what would be the equivalent resistance? That will be equal to 3K plus 5K, that is equal to 8K. So this would be the equivalent resistance of this combination. Let us look at problem number 3. It says a piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then the ratio R by R dash is which of these options? So now you have a piece of wire R which is cut into 5 equal parts. So each part will be R by 5. That means you have 5 resistances, each of resistance R by 5, and you have connected each of them in parallel. So this will how the parallel combination will look like. Both of their ends are joined to each other. So the value of each of them is R by 5. Now the value of equivalent resistance is R dash. So R dash is the equivalent resistance of this circuit. So let us try to calculate the equivalent resistance. Now from parallel combination, we know that 1 by R equivalent is equal to 1 by R dash will be equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5. So now in this case, value of R1 is R by 5. So this becomes 5 by R plus 5 by R plus 5 by R plus 5 by R plus 5 by R. So this gives 1 by R dash is equal to 25 by R, or we can say that R by R dash is equal to 25. So the ratio R by R dash will be equal to 25. So this is the correct answer. Let us look at the next problem. It says that a battery of 9 volts is connected in series with resistors of 0.2 ohms, 0.3 ohms, 0.4 ohms, 0.5 ohms and 12 ohms respectively. How much current would flow through the 12 ohm resistor? So it says that there are these 5 resistors which are connected in series, and there is a battery which is connected to this series combination. So let us suppose this is 0.2 ohms, 0.3 ohms, 0.4 ohms, 0.5 ohms and 12 ohms, and this is a battery of 9 volts. So we have to calculate the amount of current which will flow through the 12 ohm resistor. Right? Now if you look at it, this is the positive terminal of the battery, this is the negative terminal. So current will, the direction of conventional current would be from positive to negative. So that means this is how current will flow. Now since these resistors are connected in series, same amount of current will flow through each of the resistor. So the amount of current which will flow through this 12 ohm resistor is also I. So what will be the value of I? For that, let us calculate the equivalent resistance of the circuit, which will be equal to R1 plus R2 plus R3 plus R4 plus R5, because it is a series combination. So this will become 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. So this becomes 13.4 ohms. Now applying Ohm's law to this circuit, what do we get? The net voltage potential difference of the circuit V will be equal to I, current flowing through the circuit, into the equivalent resistance of the circuit. So from this we can say I will be equal to V divided by R equivalent. So V is equal to 9 volts divided by 13.4 ohms. So this is equal to 0.671 amperes. So 0.671 ampere current will flow through each of these resistance. So this is the amount of current which will flow through the 12 ohm resistor as well. Let us look at problem 5. It says how many 176 ohm resistors in parallel are required to carry 5 amperes on a 220 volt line. So that means how many resistors do you need such that the resistance of each resistor is 176 ohms, so that you are able to carry a current of 1 ampere on a 220 volts line. So what is the net equivalent resistance needed? So from the entire circuit, how much current do we want? We want a current of 5 amperes. What is the net potential difference across the circuit? That is 220 volt. So according to Ohm's law, V should be equal to I into R equivalent of the circuit. So R equivalent will be V divided by I. That is equal to 220 divided by 5. So this becomes 44 ohms. So this should be the equivalent resistance of the entire circuit. Now let us say that we would need n resistors. So now we have to calculate the value of n. So if I say that I need n resistors to achieve an equivalent resistance of 44 ohms. What does that mean? That means that 1 by R equivalent will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. How many times? N times, because I say that there will be n resistors. Now the value of each of these resistances is 176 ohms. That means their values are same. So we can write 1 by R plus 1 by R plus 1 by R. So how many times? N times I will add. So I can write it this way, that 1 by R equivalent is equal to n divided by R, because adding 1 by R n times means multiplying 1 by R with n. Right? So from this we can say n is equal to R divided by R equivalent. What is R? R is the value of each resistance, which is 176 ohms, and R equivalent is 44 ohms. So this gives 4. So we need 4 resistances in parallel so that it can carry a current of 5 amperes on a 220 volts line. Let us look at problem number 6. It says, show how you would connect 3 resistors each of resistance 6 ohms, so that the combination has a resistance of 9 ohms and 4 ohms. So let us first look at the first part. So in the first part, I want the equivalent resistance to be 9 ohms. And how many resistors do we have? We have 3 resistors, each of resistance 6 ohms. Now we are aware of 2 possible combination. One is the 3 resistors connected in series, and the other one is the 3 resistors connected in parallel. Now if you connect the 3 resistors of 6 ohms in series, what will be your equivalent resistance? 6 plus 6 plus 6, that is 18 ohms. So that is not our desired resistance, which is 9 ohms. Now if you connect them in parallel, what will you get? We will get 1 by R equivalent is equal to 1 by 6 plus 1 by 6 plus 1 by 6. So this will give R equivalent as 2 ohms. So again, that is not our requirement. We want 9 ohms. So there is one possibility that what we can do is we can put 2 resistors in series, and then we can put their combination in parallel with the third resistor. There is another possibility that we take 2 resistors in parallel and then we take that combination in series with the third resistor. So in this case, let us try the first one. Let us suppose if I assume that 2 resistors are in parallel. So if 2 resistors are in parallel, what would be the equivalent resistance? The equivalent resistance will be 1 by 6 plus 1 by 6, that is equal to 2 by 6, or Rp will be equal to 3 ohms. Now we told that 2 resistors are in parallel. Now with these 2 resistors in parallel, the third resistor is now put in series. Now the parallel combination of these 2 resistors gives 3 ohms. So now this 3 ohms, that means instead of these combination, we can say the value is 3 ohms. Now this 3 ohms is in series with 6 ohms. Therefore, R equivalent will be equal to Rp plus 6 ohms, that is 3 plus 6, which is equal to 9 ohms. So that is our desired result. So this would be the desired combination. Now let us look at the second part where we want R equivalent to be equal to 4 ohms. In this case, let us say that 2 resistors are connected in series. That means this is how we first connect 2 resistors of 6 ohms each. So what would be the series equivalent resistance of these two? 6 plus 6 equal to 12 ohms. Now with these 2 resistors in series, let us connect the third one in parallel like this. So what will happen? 1 by R equivalent will be equal to, now these two can be replaced with RS, because the equivalent resistance of these two is RS. So this can be written as 1 by RS plus 1 by 6. So this implies 1 by R equivalent is equal to 1 by 12 plus 1 by 6. So this implies R equivalent is equal to 4 ohms, that is the desired resistance. So therefore this would be the desired combination of the resistors. Let us look at problem number 7. It says a hot plate of an electric oven connected to a 220 volt line has 2 resistance coils A and B, each of 24 ohm resistance. Okay, so that means there are 2 resistances A and B, each has resistance 24 ohms. So there is one resistance A, there is another resistance B. Now they may be used separately, they can be used in series, they can be used in parallel. That means you can put these 2 resistances in series, you can put them in parallel, you can use them separately as well. So what are the currents in the 3 cases? So the first case is when you use them separately. So when you use them separately, what is the resistance? The net resistance is 24 ohms, because only one of them is used. I mean, both of them are used separately. So in one of them, the resistance is 24 ohms, and what is the voltage? Voltage is 220 volts. Therefore, in accordance with Ohm's law, current will be equal to V by R, that is equal to 220 divided by 24, which is equal to 9.166 ampere. So this would be the current when they are used separately. Let us look at the second case where we say that they are connected in series. If they are connected in series, what would be the net resistance? That will be equal to R1 plus R2, that is equal to 24 plus 24, which is equal to 48 ohms. However, voltage in this case will remain the same, that is 220 volts. Therefore, current in this case will become V divided by RS, that is equal to 220 divided by 48, that is equal to 4.58 amperes. Now let us look at the third case where we say that these two are connected in parallel. In this case, what would be the equivalent resistance of the combination? That will be equal to 1 by R1 plus 1 by R2, that is equal to 1 by 24 plus 1 by 24, that is 1 by 12. So we can say that Rp is equal to 12 ohms. Voltage is equal to 220 volts. Therefore, current will be equal to V divided by Rp, that is equal to 220 divided by 12, which comes out to be 18.33 amperes. So this would be the current when they are connected in parallel.
I hope this video on electricity was useful. If you have a feedback to share, do let me know in the comment section. I would be very happy to hear from you. If you liked the video, do not forget to share with your friends so that they can also learn from this video. I will see you all very soon with a new video, with a new topic. Till then, stay home, stay safe, take care. Bye-bye.